This is the second part about EIGRP wide metrics. Part number 2, metric backward compatibility. Remember that this network has 3 routers using IO series 15, router 1, 2, and 4. Router 3, on the other hand, is using an old iOS and cannot handle wide metrics. Router 4 is the only router in this network that has been configured to use wide metrics and has its interface gigabit to 0 down for the time being. So let's go to action item number 6. Capture traffic's coming from router 3. We're already capturing traffic. We have the capture ready here. And at router 4, turn on gigabit to 0. So let's go to router 4. First, let's review router 3 is using classic metrics. Even if I wanted to configure wide metrics in router 3, I could not because I don't have any options here to configure wide metrics. So I'm stuck with the classic metrics here. In router 4, we already have wide metrics working. So what we're going to do is now establish a neighborship with router 3. So let's go to gigabit to 0, issue, no shoot down. The neighbor should come up. So now we are neighboring with router 3, and let's see how the packets are going. So notice that the halos coming from router 3 has this version of TLV version 1.2, whereas the halos coming from router 4 have this TLV version. So we have different versions here. So let's see the update coming from router 3. Okay, we're interested in this prefix. So the information that router 3 is sending to router 4 is legacy metric, and it only sends the scale delay and the scale bandwidth. The scale delay and scale bandwidth. It is not sending the actual bandwidth or the actual summation of delays, but the scale version. So at this point, router 4 is forced to calculate wide metrics, but it needs the actual bandwidth and delay. For instance, it needs the actual on-scale bandwidth value and the on-scale delay. So let's go to action item number 7. At router 4, calculate the on-scale bandwidth from the scale bandwidth value using the metric backward compatibility formula. Remember that this is the formula that comes in the books. The on-scale bandwidth equals to EIGRP bandwidth multiplied by EIGRP classic scale divided by the scale bandwidth. And remember that these values are constant. EIGRP bandwidth is 10 to the 7th power, whereas the EIGRP classic scale is a constant that equals to 256. So according to the packet, the scale bandwidth is 16384. So let's note that down and let's calculate that. So it is this value. Divided by this value. So this gives me this on scale value. So let's check at router 4 if that is the value that it calculated. So this is the value it calculated. is this one. So notice that this bandwidth, that on scale bandwidth that router 4 could calculate is not exact, because the minimum bandwidth should be this bandwidth. So that is a problem with doing integer divisions with EIGRP. You will be losing precision. So this formula just gives an approximation of the real minimum bandwidth in the path. It will always give a value that is not exact. So that's it.